Welcome. Today we are going to see the basics of antenna theory to design. What is an antenna? Antenna is a transducer that converts a radio frequency into alternating current or vice versa. So it is widely used in the field of mobile industry, satellite as well as in the wireless technology. So this is a animated field of a definition which is called as antenna. So it acts as a transceiver where you can able to see a base station dish antenna receiving a signal from the satellite as well as vice versa. On the right hand side you can able to see the how the antenna radiates in the air. So we have seen rectangular coordinates, spherical coordinates, and circular coordinates. So this coordinating system is based upon spherical coordinating systems. Types of antenna. We have lots of types of antennas governing here, from a small sized antenna to a bigger sized antenna. So you can able to see one of the example here, which is called a slot patch antenna, array antenna, and you can able to see the parabolic reflector antenna. This is a very big antenna, and you can see the helical antenna here, mostly used in cars, old radio phones. So mostly antenna design will be pertained or stick on to this kind of types. What are the parameters of antennas? These are some of the main parameters which is governing the antenna design: radiation efficiency, directivity, gain, bandwidth, radiation pattern, and polarization. Let us take one of the patch antenna. So we call it as a microstrip patch antenna. It comes in various shapes. So these are the shapes available now. So these are the existing shapes you have here. Let us take the rectangular patch antenna design. So this antenna is more important in the industrial perspective point of view, because it is very cheaper, easily can be integrated in a PCB, and it is very rugged. It can be used in a very rugged environment at a low frequency to a very high frequency range. For example, at a range of megahertz to a terahertz of frequencies. So here we have three layers here. Number one, we have this radiating patch. Number two, we have a substrate, and number three, we have this ground plane. So this patch is a radiating element. This substrate is where it is holding the patch. This substrate can be of FR4, we call it as flame resistance type 4, or Rogers duroid, or any glass materials we can able to have. On the ground plane we have the same material which is being used for the patch. Normally we use copper for the patch and the ground plane. And what are the feeding types? We have coaxial feeding, insert feed, proximity coupled feed, gap coupled feed, aperture coupled feed. So what is the advantages of having all these feeding networks? To operate this antenna, you want to have a feeding network. You want to put a feed to bias this antenna. Let us take one example, coaxial feed. So if you have having a coaxial cable, you have to take the pin out of the coaxial and solder it on the patch antenna by drilling a wire hole at the substrate. By this method you can able to feed the antenna and bias such that it gives a good radiation pattern. A key design constraints. So this patch antenna has some constraint on height, dietary constant, width, and radiation. So to radiate this patch antenna, this length and the width has to be designed in such a way that it radiates to the free space. Because of the fringing fields which is been governing here, these fringing fields will happen to escape to the air, and this escaped radiation form a small pattern of beam which is called as radiation pattern. So this structure, this radiation has to be governed depends on some parameters: height, diameter constant, width. So height should be less than or equal to 0.19 centimeter, greater than 9.8, and which should be as small as possible. Radiation would be like minimize radiation. Effect of width. This is the effect of width. When you vary width, what affects to the feeding length, frequency, input resistance, bandwidth, gain, and half power beamwidth. So we have seen some insight about what is this antenna, and we are going to install a software called Keysoft Technologies, and from this software we are going to infer uh, a radiation, a virtualized pattern of what we have seen. This is the radiation pattern which you have learned from the theory. So this is a practice. You can able to virtually realize what is your radiation pattern in an environment by using this software. This will give you on current distribution, and this will give you the design structure of this antenna. On the day 2 you will be able to see the practical session of this ADS software which you have designed, which you have learned on the day 1, which is the microstrip patch antenna, and you will see all those parameters in this software, and we will optimize and review the result. Thank you.